There's nothing to push it away, nothing to divert it around. There is no bow shock around it. And I'm sure once we discuss it, they're going to create a bow shock around the moon.
Yeah, like they discovered that exit through the North Pole.
Yeah, and then they find out that it's concentrated at the North Pole, and it's bullshit.
Yeah, I know. Right? There's so much that is not understood because all the debunkers desperately try to deflect one's attention from what is the reality. It's doing a very major disservice to people understanding this whole situation. You know, radiation plays a part in it. I mean, we've known that right from the beginning. When Van Allen did his first testing, he knew there was radiation there. He just didn't know how much. And when he knew how much, he said, my God, space is radioactive.
Yeah, and that's just outside of the Earth's atmosphere. That wasn't anywhere near the Van Allen belt.
No, it wasn't. No.
When you really think about the amount of radiation that's coming from the sun, and that the Earth has 25,000 miles of ability in that bow shock to push it around. The moon doesn't. It's being stopped at the surface of the moon. So whatever is reflecting back out or whatever off the surface, even have a kilometer of dense radiation above the surface, right? Because it's going to be reflecting and bouncing around. It's going to be absolutely deadly.
Oh, yeah, it is.
And I'm not talking about for humans. I'm talking about for electronic equipment. How do you communicate through that much radiation? These images are of a non-functional mock-up of a lunar lander on a set that is NASA's depiction of what the lunar surface might look like.
Yes, it's what they thought it looked like.
Because it doesn't look like that. There's 3.8 billion years of cosmic dust landing on this thing. There won't be any bare rocks.
There are so many things. I've been thinking about this quite a lot recently. What are the important things that people should understand to people who've maybe not investigated quite as closely as we have? What are the important things? The heat, the radiation, and the vacuum. Vacuum is far more important for showing images than radiation. I mean, radiation does affect film, obviously. I mean, I can go into the X-ray machines at airports and all the rest of it. But the idea that you can show photographs allegedly taken on the lunar surface and use that as your evidence for man having landed there is completely wrong. That's what I want to try to cut through, that the photographs could not possibly exist if they were taken on the lunar surface.
Which means NASA has no photographic documentation of, even if they did land there, they have no photographic evidence of being there.
Yeah, that's true. Yeah. Because somebody will immediately come back and say, well, we've seen the Chinese stuff and the Indian stuff. Yeah, that's all digital. Major distinction between digital images and photographic images, which is what Apollo relies on. So people separate the two, digital and photographic. So video images can be taken, yes, I would accept that, because that's digital in effect. The hexagon spy satellite and the lunar orbiter and the pressurization to demonstrate that that's what you need for photographic film in space.
Here are the facts from those images. They had to be pressurized in low Earth orbit as a spy satellite.
Yeah.
That's factual and it's documented.
Yeah, that's the key point. It's documented by people who are not associated with the moon landings. It's something completely different, but it ties in. It's the overall consistency between space photography and Earth-based photography. But the point is, it's well known that the Apollo 11 flag was supposedly knocked over by the blast of the takeoff. Hang on, blast of the takeoff of a smaller engine, and it blew the flag over.
And didn't disturb it at 50 inches.
Yeah, but the more powerful engine below it didn't move a speck of dust. I mean, that's just non sequitur.
Non sequitur is an understatement.
Exactly. The idea that you can show that the legs did not compress because the mylar is not compressed, the mylar is not affected. When they were using it as a stage set, it was a simulator lander. It wasn't the real thing, which weighed about 15 tons.
The ladder proves that it's not compressed because that ladder would be just about touching the surface, closer to it. It's not.
That's probably what it was designed to do. They knew it would compress, or they assumed it would compress. they didn't put the ladder further down because it would damage it. So the ladder was 30 inches above the ground, but it didn't compress. Aha! No compression.
You see, that's how you can get them, because if they're going to say, well, we can't see the foil compressing, but it may be inside. How do you know that the foil's not wrapped around it? You get what I mean? It could be free floating like a tube. Well, if that's the case, then let's take a look at the ladder, how far that ladder is from the surface. So that means if the ladder is not closer to the surface, those legs have not compressed.
No, they haven't. I think it's a very key point there.
Well, they'd have to put the foil on after they landed. And there is documentation on Apollo 11 that lower leg, that 32 inches, was added after it was loaded into the Saturn V rocket. They decided to add that to the legs afterwards. And it added between the four, just those four little pieces, 32-inch long, added 38 pounds. That's how much the foil weighs when they landed them on there. Now, when you get to Apollo 14, they didn't have any on the lower part of the leg, and it didn't seem to affect it if they landed. So why wouldn't they take off 300 or 400 pounds of mylar off the vehicle to make it lighter for 15, 16, and 17 if they see in the photographs that it was actually functional without it?
Yeah, because it wasn't.
No, because it's just on the set. And like I said, that it just got soaked with water on Apollo 12, and then they took it off for the next thing. It was getting all moldy and everything else in there. You can see it in Apollo 12. They just removed it. Soaking wet. You do realize that the first car manufacturers were afraid that they would kill people if they built a car that would go 100 miles an hour?
Yep, I remember that.
We couldn't build a car that fast because you'd be dead if you were going 100 miles an hour. Just the speed would kill you.
Yeah, the pressure of the atmosphere on your chest would kill you, was the first explanation given. I always say that my great-grandfather, who lived in the 1840s, 1850s, in southern England, he was a doctor, the fastest he'd ever traveled was on a galloping horse, about 30 miles an hour, possibly, if you get a really good horse. But beyond that, he had no experience of fast travel. In the last 200 years, we've gone from galloping horses to space rockets.
Underneath the Apollo 11 LEM, look how bright it is under there. You know what? There's no lines. There's no blast lines. There's no radial lines from that engine coming out anywhere under there. It's like they just raked it over. But then yet, look at this, is taking off. And look at all the stuff being blown. And that's only a 3,000-pound engine. What did they land with? It was double that. So there should have been more.
Yeah, exactly. The idea that the engine has no effect is just ridiculous. We can demonstrate that it does have an effect. I checked his website, which is quite interesting, because he's got a section on there about the Apollo hoax and all the rest of it. He makes some very, very simplistic comments, but he talks about the gravity. That seems to be the subject he's concentrated on. Just talking about gravity. How can you fake the gravity? I say, well, that's the easiest thing in the world to fake. You know, it's so different from Earth gravity that it would be obvious if it wasn't. So of course they're going to fake it. Well, how do you fake a feather falling in a vacuum? As if that is a problem. You know, like it's called lead. You put it in and it makes it heavy.
And of course, it's also the way you drop it. Do you drop it like this, or do you drop the feather sideways?
Yeah.
Where's your reference point? Where are you dropping it from? Right? Yeah, and like you said, put some lead on there. Put a little bit of weight on there and watch how fast it falls.
In fact, Dave Scott was very keen to say that it was a falcon feather because his craft was called the Falcon. So it sort of tied in, you know, made a good story, and everybody could go along with it because, oh, it's Dave Scott, it's Apollo 15, and he's got this hammer and this feather, and he can draw a falcon feather. Wow, how good was that? Brought it all the way from Earth, as if that was important. And he dropped it, and look, they all fall at the same speed. Well, of course they bloody fall at the same speed. You wouldn't show it if they didn't.
You know what's interesting about taking a high-speed camera and playing around with it? There's these guys, it's called the high-speed guys, I think. They're using their cameras at thousands of frames per second. But if you were to take a camera, high-speed camera, and you only go about maybe 500 frames a second instead, you have an astronaut just walking across the surface, just doing his little thing. What do you need wires for? Because when they're walking across and they're doing their little thing, well, if you take a camera that's 500 frames per second You do your thing, let them go, and then slow that down. There's your sixth of gravity. How do you think they get tiny little models? When they falls, that's what gives it the gravity.
Yeah, of course it is.
It's going to happen the same with an astronaut. So why would you need wires and all that kind of stuff on them? You're not going to need it if they're just bouncing around, in the suit there and walking and sliding and doing their little bunny hops. And you do that and then slow it down. Of course, you're going to get the floaty effect.
Of course you are. I mean, that's the sort of thing Hollywood's been doing for a century. It's been showing things on screen which were not real, but because it was shown in a particular way. I mean, remember that famous sequence of Harold Lloyd, I think it was, on the clock. He was hanging from the arms of the clock.
Yeah, I always wondered about that because, in the past, you're looking at this, you go, how the heck is that? Look at this guy falls, he's dead. And then look how they jump cut it. They show you a perspective from the ground, and it's like, holy smoke, this guy really is up there, but they're jump cutting the cuts in there, right? And you don't realize he's not even, 3 feet off the ground.
Well, also on that particular sequence, to keep the ground a long way away, he had a safety net underneath him out of shot. So if he fell off, he'd be in a safety net. How can he do it? Oh, it's the same with, the Buster Keaton shot of him when the building falls and Buster is in the window. I mean, that was just careful measurement and some nerve from Buster Keaton to make sure he didn't duck when it fell because he'd get hit by the wall. They were certainly doing some very dangerous stunts in those days.
Can you imagine that? Just a couple of inches off and you'd be flat.
I know. All I'm saying is that Hollywood knows how to do that sort of thing, how to make something that is supposedly real not as dangerous as it appears when it's on film. And Hollywood's been doing it for years. I mean, some of the stunts in Fast and Furious, ridiculously dangerous stunts, apparently, until you see the CGI behind it. But the idea that any photographic film could be used on the moon in unprotected cameras is just so wrong and so easy to prove, which you've already done that. We can prove that photographic film is effective, and that's one of the points I'm going to emphasize very hard, to say that photographic film cannot be used in a vacuum. I think we've demonstrated conclusively that photographic film outgasses. For whatever reason, it outgasses. Which is why I can say, I think quite confidently, that no film photograph could have been taken on the lunar surface, given the level of vacuum we know exists there, because the colors were not affected.
I don't agree. And Bill said the same thing after he had finished all this, when he said he doesn't agree that the film would just go brittle and crack and do all that kind of stuff. He said if it did, you'd have to leave it there for an awful long time. But it's a whole different thing when it fogs. Now, the film that his friend gave him, he took a bunch of film of lemon trees. Look at the fogging.
Yeah, the fogging is noticeable.
This was one that really went bad, this one.
Oh, God, look at it. Yeah, it's completely fogged.
And to boot, it's damaged. Right? He was so careful. We were so careful with this film.
Well, obviously, you have to be careful to make sure you get it right. Make sure everything can be recorded accurately.
But even this, look at that. That is really nasty.
Yeah.
So's this.
Yeah, it's quite bad. I think that's one of the strongest arguments. And I've never seen this discussed by anybody else other than to try to debunk it. In fact, I don't think they've even debunked it very much.
Oh, my God, yeah, look.
Oh, Christ. Yeah, okay. That's badly filmed.
They're just comparisons. That's all they were.
Oh, yeah. No, well, he shows it very clearly. But it's certainly true what Bill says, that the plastic backing would take much longer to be damaged because the vacuum's not hard enough at that level. The vacuum level that he was using affects the color balance of the film because it outgasses the film, but it doesn't necessarily destroy the plastic backing, the polyester backing. That's slightly different. To say that it would be too brittle to go through the cameras may be wrong in terms of what you're doing here. But I think it would apply on the moon if they were putting a film through a camera on the moon, unprotected.
Cornelius Crew says, oh, yeah, well, it proved you could still take a picture. You still took a picture. I says, yeah, but look at every color picture that those guys on Apollo took, right? They're pristine. You don't see colors bleeding all over the place. And here's the big one. Where's the fog? There's no fog on it.
No. Maybe try to debunk it in a roundabout way, but it's not effective if you know what you're talking about. I mean, we know what we're talking about, and they're desperately trying to remove the points that we are making by trying to equate it with other things. That doesn't work.
This was the film that was sitting inside that little chamber they had. It's ruined.
Yeah, it is. Look.
These are just clean right off of the film. I mean, wow.
Completely different. Where's the green of the grass? Where's the blue of the sky? And I think what's happening here is that one of the frequencies, it looks like it's the blue frequency has gone and the red frequency predominates. And that's what's being recorded. So you've got infrared, there's quite a short wavelength. Ultraviolet, the blue wavelength, is completely different. Tends to get a bit technical at that point, but I think that's the reason why one color dominates over the others.
Yeah, it's definitely blue. This is really fog. This is interesting, these little bushes here. This is the control here. This is what happened after the vacuum here.
So the blue is a predominant color there.
Yeah, it's always blue.
Yeah, it is. And I think that's to do with frequency. The frequency of blue light is different from the frequency of red light. Therefore, the emulsion that records the different colors, the red or the blue, will be affected differently in a vacuum. And the red will be affected far more than the blue. Why do we see the sky as blue? But the sky is in a vacuum if it's high enough and there are no clouds.
That one physics professor, he did a demonstration of why it's blue, and he was using smoke for an experiment just to show that it's got to do with the wavelengths, and there's particles in the atmosphere and it's bouncing off the particles, and that's what's giving it the bluish hue.
And also, when you take a normal photograph of mountains in the distance, they're always slightly blue tinged, which is what appears in the photograph. It's a blue tinge, which is, again, the effect of wavelength. Red doesn't show up nearly as much. Therefore, in photography, you have filters to make sure that you get the right color balance. And if you want to remove some of the blue, you can do that quite easily using a red filter. It's always the reverse. Or use a polarizing filter, which affects the frequency. And they had that on the moon, would you believe? They told us they had polarizing filters. Well, it's a ridiculous idea, polarizing filters. That's why I think the people who were behind the photography knew a great deal about what they were doing, but they didn't know enough to remove some of the questions that we now have about how certain photographs were taken. And because most people are only familiar with digital cameras and not with photographic cameras, like our friend Dave McKeegan, who probably hasn't used a photographic film in his life, they don't know the difference. So they're comparing apples to oranges. They're not comparing apples to apples.
There's the comparison. So there's the first tree there. There's 1, 2, 3 trees snapped across here. Well, some of them didn't turn out, so I guess it all depends on what sequence I took them in. But the 3 trees that are going across here, there's your 3 right there. But yeah, that's crazy. Just look at the difference in those trees. Oh, there's 1, 2, 3, 1, 2, 3. Okay, and it's always so blue.
Yeah, it's a predominant blue color.
Same down here. Let's see these ones. So there's 1, 2, 3, 4, 1, 2, 3, 4. So there's that 4 set there.
And they're so blue. I mean, even on the small contact sheet, you can see them as blue, whereas on the other ones, they're not.
But this was the stuff I sent to Bill, control roll, and then that one was the one that went in the chamber. And that was the one where you could see it in the chamber. You could see the front of the chamber's glass slowly fog.
The more it outgasses, the more it condenses.
And then he had his friends in there as well. That's the lemon tree.
What was Bill's final conclusion on it?
Well, his final conclusion is that it ruined it, because not only with this, what he did, but when he was cleaning out the chamber, there was the same type of stuff that filter caught. It's black. So all that black stuff was coated around. It was sticky, he said. It was a sticky black stuff that was coated around the outside of that entire chamber.
Wow.
In the walls. He said there was more on the walls.
So he was able to confirm what you had already identified. The photographic film outgasses in a relatively low vacuum.
The magic really started happening when he hit -2. That's when it started to fog.
And that's quite low. I mean, that's a low vacuum, -2. When you get to the moon at -12, nobody knows what's going to happen there because nobody's got a vacuum chamber that can do it. Not that I know of, unless Mr. Toon knows somebody who's got a vacuum chamber that can pull taut to the -12. I'd like to see him try.
Well, see, they all say the same thing, as well as some of these other channels. They say, well, yeah, well, we've done it. Well, I've done it. Some of the people in the comment section have said that, well, I've done it. We've put it in there and didn't do anything. Well, what kind of a pump were you guys using?
Yeah, easy to say it, isn't it? Trying to disprove what we've demonstrated.
But you know what was good about this? Is that we had it independently tested by a university. This is where it gives you credence here, because the university's seal is on this.
Yeah, it is. Their reputation stands on it. And it's somebody who is professionally involved in testing vacuum on products.
That's what he has to do.
Yeah, because there are people who want to know what effect a vacuum will have on particular items that they want to produce commercially. So you've got to get them tested properly. Not wishful thinking, proper testing. And I think what Bill has done has been a very valuable contribution to what we've identified. And as I say, there are very, very few people who are, other than just making statements, doing the testing. The testing that you've done, testing that Bill's done, the talks that I've listened to that demonstrate it. What effect does Phil Pressel have? Because he's worked with it, he understands it. He knows what he had to do to produce the results that were required, i.e. the photographic results from space. He knows what had to be done. He wasn't trying to do shortcuts. It's interesting. One of the things that, people say, oh, you can't keep a secret. One of the points that Phil Pressel made during his talk said, my wife did not know anything about what I was doing. I could not discuss it with her. I did not discuss it with her. So she was completely unaware of all the work I was doing. That's called national security, keeping a secret. It's what people do. Most people are honorable, and if they agree to maintain a degree of secrecy, they will. They won't go down the local bar and talk about it to everybody they can find. Of course they won't. So the idea that you can't keep a secret is so much rubbish as well.
I mean, he said the same thing. Film is ruined in a vacuum, right? That's why we have to put 2.5 pounds of pressure, 1.7, 2.5. It changes depending on what video you watch or what article you read. Sure. But it doesn't matter. It has to be under some kind of pressure. That's the whole point.
Yeah.
Now, when you take it away, I mean, it would be fantastic if these astronauts on the space station would just put a roll of film out there, just leave it out there for a day and then bring it back in and develop it and let's see what's going on. They won't do it.
No, because it would blow the whole story apart. I think that's the one area which will cause more problems than anything else.
Was it Starliner, the escape capsule? With all those rockets on it? I don't know which one it is. I don't know if it was Bezos's or Boeing's or which one it was, but they're testing the system in case the rocket blows up. All those rockets fire on the outside and it takes the entire capsule to safety. This is in an environment. This is in a full gravity environment. And why did all the thrusters work to take this thing away to safety? And yet it doesn't work in space.
No, not enough gravity.
Oh my God. Do you know what's happening with these guys now? Because there's not much on it. They just said that SpaceX is going to be going up to pick them up, but then it got halted. This was yesterday. If you were an astronaut, I don't care how brave you are, would you get into that thing after seeing what happened to Challenger and after what happened to Discovery? I wouldn't get in that thing. You'd be nuts.
You would. That's why they're going to wait for SpaceX to rescue them. And I think that NASA have now voided the contract. They're no longer relying on Starliner and Boeing. Remember Boeing, who make planes the doors blow out from? Oh, dear.
And this is another thing that doesn't make any sense to me, is that Boeing was right there at the heart of the Apollo age. As soon as it started, Boeing was there. It was Boeing this, Boeing helped to make the LEM, and Boeing helped to make the rover. Okay, well, these guys have had 60 years in space travel, and building spacecraft, and building rovers, and building LEMs, and reaction control systems, and all this stuff. And then 60 years later, they build a vehicle that took them 10 years to build and figure out and test, and failure after failure. And then they finally put this thing up there, and guess what? It fails and almost takes a couple of lives along with it. Now, does that make any sense? How can Elon Musk, a guy that comes along out of nowhere, and he all of a sudden, oh, well, it's no problem, we'll make it work, and it works. And it only took him, 10 years to do it? Yeah. Something like that. But then these guys have had 60 years, and yet it doesn't work. And yet they were the ones that were supposed to have helped get man to the moon. Just think about that for a minute, how ridiculous that sounds.
I know, it's absolutely stupid. The idea that you can have something that gets man to the moon, but you can't do it 60 years later because you've lost all your plans, or they're on microfiche and you can't get a machine to read them, or they're all on tape and you haven't got a machine to read the tapes. You know, how stupid is that? Because that's the excuse they come up with. Oh, we've got the tapes, but we haven't got the machine to read them. Well, make it. You must have the plans for the machine. Recreate the machine.
Oh, here was another excuse that I heard not long ago, was that, oh yeah, they have the microfiche readers. That's not the problem. It's getting the lens for it, because they always take the lenses out of those readers before they go back into market for sale. And it's trying to get a hold of the lens. That's the key part.
Well, they must know what the lens was manufactured, what tolerances it was manufactured to when they made it the first time. Make it again.
Okay, so then we get to this. And I have a question about this because this is not making sense to me personally.
Okay.
And I'm going, why would these guys be spending all of this money, taking all of this footage, and we don't see any of this footage in any Hollywood footage? So what are they doing with this footage? And that's what I'm going to show you, because it makes no sense to me. Here's these guys up in the ISS. Felix and Paul sent these special 3D cameras up to the ISS, and the astronauts are the ones that are taking the photos for them. And then they're taking those videos and recreating them on Earth in their studio. So, watch this. The guy's telling you how they're doing it, how they did it, and all this stuff. They're giving you all the information down here, you know. And but watch what happens. This is how we did it. Watch this. There's camera one.
Yeah, okay.
And of course, she goes out of the camera. Now, there's camera 1 and 2. See what they're doing? They're rotoscoping her from camera 2 into that same image. And then watch what happens when the rotoscope goes over. And then watch what happens when they color correct it all. Seamless.
Yeah.
This is my point. What's the point in this? Why would they spend all this money putting this all together?
Why would they make it? I mean, what's the purpose behind it?
Then you get to the space station and you're wondering, wait a minute, how the hell did these guys get all this footage outside the space station? Are they using a drone out there, like with jets, like little motors? So I went looking for it, and SpaceX, they're making a drone to do spacewalk footage, but it doesn't exist yet. Well, look at the rotoscope technique. You mean, you know yourself how old rotoscoping is? That's going back to the Bugs Bunny cartoons.
Yeah, it is. Yeah. And she's drifting through part of the space station, which she's not supposed to be able to get through. It sort of looks impressive. It's so that Congress will keep funding it, I suppose.
But okay, so these guys are in the International Space Station, right? There's one of the modules here on Earth. They show you the studio. They show you the whole setup and everything. This is from calibration point here.
It's a nice accurate zoom as well.
Okay, well, the International Space Station is there, but why do they need all this crap?
Yeah, exactly. I don't know. It's probably to do with PR. You know that famous quote from Richard Feynman? No matter the requirements of PR and propaganda, nature cannot be fooled.
Now watch this one. I'm thinking, oh, wait a minute. Where's the camera? So I'm going, okay, well, let's have a look at this for a minute. The ISS experience now, of course, Felix and Paul Studio, they're doing this, and there's the cupola, you know. Just wait, it gets better. What's some of this photography? So I went and I looked to see again, right? I wanted to know where this camera is on that station and the space drone. What drone are they using? Well, there's your life tether there. He's explaining all this and how they're tracking and the camera tracking. It's crazy. These guys are spending millions of dollars doing this. Now look how close the station is to the Earth. It's just about touching it. This is another one of the modules that they shoot in. But you'd think, where is all this footage, though? Do you see it in movies anywhere?
No.
Like, I don't see it in any films or shows. I don't see it anywhere. Okay, well, the space station's up there. But I tell you something, I don't think they're doing what we think they're doing up there. Why would they have to do this in a studio? In a studio.